Now that you've learned some of the basics of game programming like processing data, reading user input, and displaying text and images, you're ready to create your first multiplayer game. In this tutorial, you'll learn how to query multiple controllers for user input and count button presses through edge and level detection, which I will explain later. You will use these skills to create Button Bash, a game in which players compete to see who can press a button the most in a given time period. Simple, yet loads of fun at parties when you get 16 people involved. Alright, well, let's create a new project and call it Button Bash. Button Bash is going to be a Windows game, and I'm going to save it to my desktop. Okay. Well, I already know that I need to display text on the screen, so we're going to load a font the same way we did in a previous lesson. Go to the Button Bash content folder, right-click on it, go to Add, and select New Item. Click on the sprite font, and the default name is Sprite Font 1, so we can keep that, and click Add. The default font is Segoy UI Mono, and the default size is 14. Let's change that size to 30. Pause the video and add the sprite font. Go back to the game1.cs file. To create a 16-player Button Bash game, we're going to start by focusing on one player and one button, and then scale up from there. Let's start by writing code to record the number of times the B button has been pressed on controller 1. Create a count variable near the top of the game1 class. Int count is set to 0. We need a way to start the game other than running the game by pressing F5. Let's query the controller, that means check or ask the controller, and see if the start button is pressed. If it is, we'll set count to 0. Pause the video and add this code. Go to the update method, and along the way I'm going to shrink these other methods because I'm not going to use them right now. It's just the organized side of me. Here we are in the update method. Let's go ahead and ask the start button if it's been pressed by first creating a gamepad state variable. Call it pad1. And it's equal to gamepad dot get state player index dot 1 and we'll ask pad1 if pad1 dot buttons dot start is equal to button state dot pressed. We'll set the count to 0. Now let's write the code to count the number of times the B button is pressed. I'm going to copy and paste this conditional structure and change it just a bit. If pad1.buttons.b is equal to button state.pressed, I'm going to increment count by 1. Pause the video and add this code. Wonderful. Now that we can keep track of the number of times the B button is pressed, we need to display it on the screen. Let's create a sprite font variable to represent the sprite font file we created earlier. Go to the top of the game1 class, and along the way I'm going to shrink some of these code sections. And under int count equals 0, go ahead and create a sprite font variable called font. And let's go into the load content method and load that font. Font is equal to content dot load, and we're going to load a sprite font, and it is called sprite font 1. Excellent. Pause the video, declare the sprite font variable, and load the sprite font. Now let's go to the draw method to display the value of count. Let's first create a string to hold the text form of count. String count string is equal to count dot toString. So what this does is that it turns the integer variable count into a string. And so we're able to display it on the screen. Now let's create the vector for placing the text on the screen. Vector2, we'll call it count vector, is equal to a new vector2, and we'll set it up for 200, 100. Great. Now let's actually draw the count text using the sprite batch. Sprite batch dot begin. We are going to use the drawString method and give it the font, the count string, and then the count vector, and we'll draw it with the color red. Now we end the sprite batch. Pause the video and add this code. Great. Now all we have to do is see it in action. Seems to be something wrong here. I know my button bashing skills aren't that good. And what happens if I just hold the button down? Youch. This is happening because the update method is being called 60 times a second. And so, if the B button is being held down, like this, it's updating at a rate of 60 times a second. This brings us to the topic of level and edge detection of button presses. What we need to do is register only one button press if a button is held down, and count multiple button presses only when the button is let go and pressed again. A button press should only count when the state of the button has changed from up to down, and not down to down. This is called edge detection of a button. Edge detection would be used if we wanted a button to make a character on the screen sprint by tapping a certain button, while level detection would be used if we wanted the user to hold the button down to sprint. Let's go to the update method and write code to perform a test along the lines of, if the button was up last time and is down this time, the counter should be increased. To do this, we'll need a second gamepad state variable to hold the state of the button the last time update was called. Let's go to the top of the game1 class and type gamepad state old pad 1. Pause the video and add this code. Now go back to the update method and type start button's pressed, we set count to 0, but we also initialize old pad 1 to pad 1. Now we need to change the condition under which we update the count variable. So instead of just the B button being pressed, we have to say if the old state of B was equal to button state dot released and the current state is pressed, count plus plus. The last thing we need to do is set the old pad to pad 1 at the end of the update method. Old pad 1 is equal to pad 1. What this means is that the next time the update method gets called, old pad 1 will hold the previous state of the gamepad. When the next update happens, the pad 1 variable will be reassigned the current state of the gamepad. With this code, we are able to check if the button was up last time using old pad 1 and is down this time using pad 1, so we can increment the counter accurately. Pause the video and add this code. Let's run this and check out the edge detection. Awesome. No matter how long I hold the button down, it's just going to register one press. To actually register a press, I have to let go and press the button up and down. Awesome. The only thing left to do now is to apply this code scheme to the A, X, and Y buttons on the Player 1 gamepad, as well as the buttons on the other gamepads. Let's start with the variables we'll need at the top of the class. And so I'm going to keep my sprite font, and the count is going to disappear because I'm not just counting the one button anymore, but I'm going to count multiple buttons. The sprite font right there. And I'm going to create a whole suite of variables for gamepad 1, starting with not only an old pad, but a new pad as well. And now I also need to make separate variables for the ACount button on player 1, as well as the same counts for B, X, and Y. As a reminder, the A button is green, the B button is red, the X button is blue, and the Y button is yellow. In addition, I'll need to set up vector 2s to represent the text positions of the button counts for each of those buttons. A position 1 is equal to new vector 2 50, 150. Let's copy that, paste that a couple times. B, X, and Y. Let's put this at 200, 100. 100, 100. 150, 50. And so now I need to create a similar set of variables for all the other gamepads. You might be wondering where these numbers are coming from. With XNA Game Studio 4.0, the screen is sized to 800, 480. 800 being the width, 480 being the height. Now if you're dealing with a different screen size, your vector 2 x and y's will be different. Now let's do gamepad 3 and gamepad 4. Pause the video or review it if needed and type in the code. Now let's restructure the update method to work for the A, B, X, and Y buttons on all 4 controllers. First, we initialize the gamepad states for all 4 controllers. Now let's write the code for pad 1, beginning with the start button. We should only query pad 1 if it's connected. To do this, let's use a Boolean property of the gamepad state structure called isConnected. Now let's set the start button to set all button counts in the game to 0. So with this code, the start button on pad 1 will reset or set all the counts to 0. And that will be the official start of the game. Pause the video and add this code. Now let's code the count increments for the A, B, X, and Y buttons on pad 1. Now let's code pad 2. Pause the video or review it if needed and type in the code. Now let's restructure the draw method. Let's start with pad 1's count data. Go to the draw method. Let's delete this stuff. And here we'll say if pad 1 dot is connected, we'll go ahead and draw all the pad 1 button data, where it's the font, and we're going to go account1 dot toString and use a position1 and we'll go color.green because the A button is green. We're going to do this for the other buttons as well. Now let's do the same for pad 2, pad 3, and pad 4's count data. Pause the video or review it if needed and type in the code. Okay, let's go ahead and run this and see what happens. Alright, awesome. Well, now that we can register all 16 buttons using edge detection, we could actually stop and be satisfied. In user testing, a very important part of the programming process, by the way, we'd find out that because the game does not set a time limit or button press goal, people are using their watches or an agreed upon number of button presses to decide the winner. While this seems like an okay way to limit the game, players are still sneaking in a couple button presses after the game is supposed to be finished. Let's create a rudimentary timer to set a time limit on our game. Whoever presses their button the most before the time runs out will win. We will use the fact that the update method cycles 60 times a second to help us keep track of the time. Let's go ahead and look at some code. Create a variable at the top of the game1 class called timer and set it to 0. Pause the video and add this code. Now what we want to do is allow people to change their button press amounts only if the timer is less than a certain limit. We could do this by wrapping all the button press code in a conditional block to control it, but instead we're just going to control a couple of statements, the updating of the controller states. Let's create a condition near the top of the update method after the code that controls the exiting of the game. If timer is less than 300. Because the update method is called 60 times per second, every 60 ticks is worth 1 second in game time, and we just multiply 60 by the number of seconds we want to play the game. I set it to 300 to represent 5 seconds. 60 times 5 equals 300. Now we'll use the condition to control all the gamepad getState code statements. Lastly, we'll increment the timer at the end of the update code. This code will allow players to update their button presses only if the timer is less than the limit. When we reach the time limit, the screen will continue to be drawn so that we can see who won, but any extra button presses will not register because the states of the controllers aren't being updated. Pause the video and add this code. Let's see the game in action. Five seconds is pretty quick. You might want to change it to 10 seconds or even 20 or 30 seconds. As an extension exercise, try to add some vibration and color changing effects at appropriate times. You could also try to make the goal a certain number of button presses rather than a race against time.